Hey guys, Mr. Prusky here. Hope you're having a good day so far. Excuse me. We are continuing this chapter learning about areas of different shapes, including circles and triangles and rectangles, all that stuff. We're doing more work with circles today. The video got chopped off a little bit from 11.4, so I thought we'd do a brief review of what you missed in there to make sure that it's covered in the video, and then we'll move on to the next lesson for today. The first 11.4 lesson was about circumference, which is the outside of the circle or the perimeter of a circle. So if we have, let's actually do this. Nope, that was bad. A little better. All right, so if we have a radius and we have a diameter. So the formula for circumference of a circle is pi times diameter, or 2 pi r. There's a jet going by. That's pretty awesome. So basically, there's a few ways you can solve this here. Basically, you have to think about what you have and what you're looking for. So, for example, if we're looking for, and the reason why it's pi d and 2 pi r is this. A diameter is how many radii? It's 2 radii, and a radius is actually the diameter over 2. So that's why we just have one diameter here and we have 2r, because they're essentially the same thing. They're essentially the same thing. Why is it not wanting to go? So basically it's the same formula. You just want to think about what you have, what you're looking for. If they give you the diameter, you're going to want to solve for or you want to use the diameter. If they give you the radius, you're going to want to use the radius. So let's do it in a couple examples here. So if we're looking for the circumference and they give you the radius equals 4, if the radius equals 4, which one are we going to use? Are we going to use c, pi d, or 2 pi r? Which one has the radius in it? 2 pi r does. We're going to do c equals 2 pi. I'll put r first. Then we just plug in 4 in for r. So c is going to equal 2 pi times 4. And the exact answer is actually going to be 2 times 4 is 8. And we get 8 pi. That's the exact answer, because if you want to multiply by pi, it makes things like you have to round. It makes it a little clunky. But 8 times pi, usually we want an approximation to 8 times pi is, delete, about 20, I gotta do approximately 25.13 units. Okay, let's do another one. Now let's do this one where, let's see here. We're looking for the circumference, and they give us the diameter equals 10. All right, well, if the diameter equals 10, which one are we going to use? C, pi d, or 2 pi r? We're going to use pi d, because they give us the diameter. So C equals pi times the diameter, which is 10. So C equals 10 pi. And then C is going to be approximately 10 times 3.14 is going to be 31.41, I believe, 42. Let's just multiply that real quick. Yeah, 31.42 units. Okay, so that's just kind of a brief review of that. Let's do one more example. Now let's do something different. Now let's find the radius given the circumference. I'm going to look for the radius, and I'm given the circumference equals 100. Let's not do 100. Let's do 40. Okay, I'm looking for the radius. I know the circumference is 40. So which one am I going to use? 2 pi r, pi d, or which one of those am I going to use? I'm going to use 2 pi r. I'm going to use c equals 2 pi r, because we want to use one that has the variable we're looking for. And I'm going to plug in this 40 in for c. So I'm going to plug in 40 equals 2 pi r. All right, and now how do I solve for r? How do I get rid of that? This is all multiplied right here. How do I undo multiplying by 2 pi? I'm going to divide by 2 pi. So r is going to be approximately, be careful when you divide that you put parentheses around the pi, the 2 and the pi. Oops, it goofed. 40 divided by... Messed up again. It's about 6.37 units. Okay? So I actually might use this I'm going to upload this version of the notes. It's a little bit better looking. So that's just a review of yesterday, the first thing we missed in the lesson. Today's going to be more of like the second section we did, where we did the part over whole equals part over whole. But yeah, so let's go ahead and get into this lesson. What's the name of the lesson? The name of the lesson, ready? 1, 2, 3. Areas of circles and sectors. Essential question, ready? 1, 2, 3. How do we find areas of circles and sectors? All right. So, I forgot to mention that I actually recorded the lesson and it didn't have sound again because I updated my iPad. And so that was a little frustrating, but took a break and we're doing it again and just making sure you guys know what's going on here. So, all right. So, a sector of a circle is the area, the what? The area bounded by two radii of the circle and their intersected arc. So a sector of a circle is going to be something like this. Here's a circle. Here's the center. That looks sloppy. I'm going to fix that. So the area of the sector, it's bounded by these two endpoints right here. All this section in here is the area. This is a sector. Okay? This is a sector of the circle. All right? And the formula for area of a circle is, it's not pi d, 2 pi r. It's not got 2. We only have 1 to work with today, which is kind of nice. It's only pi r squared. Area equals pi r squared. You guys may have heard that before. But yeah, so circumference is usually 2 pi r, and area is pi r squared. Okay? All right, let's keep moving here. So, find the indicated measure. Find the formula. Use the formula for area of a circle. We're looking for the area, and we know what is this 4.2 right here? Is that area? Is that area, radius, or diameter? What is that? We know the radius equals 4.2. So again, we're going to use the formula area equals pi r squared. We're going to plug in this 4.2 in for r. So area is going to equal pi times 4.2 all squared. So A, I'm just going to multiply that all out. A is approximately, when we do that, we should get 55.42. Now, is it going to be meters, or is it going to be meters squared if it's area? It's going to be meters squared. That's all there is to it. All right, now the next one's a little bit trickier, but it's still the same formula, kind of. We're just going to do something a little bit different. So in this time, we're looking for the diameter, and we know the area, which is 201. So we know the area equals 201. We're still going to use area equals pi r squared, because that's the only formula we have, really, for area of a circle. But we're looking for the diameter, which we'll try to figure out later. We can do something with the radius later to figure out the diameter, which you guys will see. So we're going to plug in 201 for area. 201 equals pi r squared. Now, how do I solve for r? This is a little tricky. Am I going to get rid of the pi first or the squared first? Usually we do the opposite of order of operations. So usually we would do multiplication and then exponents. We're going to do the opposite. We're going to get rid of the pi first. We're going to divide by pi on both sides. So 201 divide by pi. So this one, we got 63.98, which is really close to 64. So we're just going to say 64 for the purposes of this example, because I think that's what they wanted us to use. They just put an approximation of 201 here. So, all right. Now, how do we undo a square? We do a square root. So r is going to equal 8, because the square root of 64 is 8. Now, how do we find the diameter? The radius is 8. Is the diameter going to be double or half of the radius? The diameter equals double the radius. That's not a radius. So it's going to be 2 times 8, which equals what? 16. And it's going to be inches, actually. And there's our answer. All right. So that's very similar to what we were doing up here with these last couple examples. So hopefully it's making good sense. All right, now we got another version of kind of not yesterday's, but like 11.4, that kind of stuff. So it's the same principles as before. Just don't panic and stick with me, and you guys will be okay. So, area of a sector. Again, we are going to do part over whole equals part over whole. All right? So what this should say here, it should say area of the sector over area, or pi r squared, is going to be the same thing as the arc measure over 360. It's going to be proportional. It's going to be the same ratio, basically, all right? We're going to get rid of that bottom one. I don't like that bottom one very much. So the formula is going to be this. The formula is going to be area of a sector over the whole area of the circle, or pi r squared, whichever one makes the most sense for the problem, equals arc measure, basically how many degrees that area of that sector covers, over 360, which is the entire, how many degrees a circle makes up. Okay? So let's go ahead and do an example. All right, find the areas of the sectors formed by RQS. RQS. Okay, so we're going to do, and when do you use these top equations and when do you use the bottom these kind of equations? You use these kind of equations when you're working with sectors. If you're working with the entire circle, then you're going to use like these just pi r squared and stuff, okay? Same thing with these other ones up here. If you're looking for the circumference or just the diameter or just the radius, and they don't give you a sector or a arc length that you have to work with, then you're just going to use that formula to work with here. So you're only going to use pi r squared if it's just like for the whole circle, basically. All right. If you're using part of the circle like we're doing down here, we're going to be using the area of the sector over area, pi r squared. That's going to equal arc measure all over 360. Okay. So, do we know the area of the sector, or is that what we're looking for? That's what we're looking for. I'm going to call that x over. And then, do we know either the area or the radius of this circle? You guys see the area, the radius of this circle? We see the radius is going to be 5, so I'm going to use probably pi r squared, because we got to use the formula that has the thing we're using. So so pi times 5 squared equals, do we know the arc measure? Do we know the arc measure? What's the degrees of the sector there? 63 all over 360. Okay. And then now we need to cross multiply like we do for all proportions. So we're going to go like this. So we can go up here. And I'm not going to do that. Just go like this. So we got 360x equals. Now what I would do, guys, is I would multiply, I would do 5 squared is 25 pi. I would multiply 25 times pi times 63 like this in your calculator. Okay, that'll make things a lot easier. Or you could just do, you could also do 25 times pi times 63. Or you could do 5 squared times pi times 63. Either of those would totally work. And then so that's going to be approximately, when we do that, we should get approximately 4,948. And how do we solve for x now? How do we undo this times in the middle by the x there? We're going to divide by 360, so x is going to be approximately, I got 13.74. And there's no units, so we put units squared, because it's still an area, but we don't have a units for this one. And there you go. Just plug it into the formula. All right. Why don't you guys go ahead and try checkpoints 1, 2, and 3 really quick, and just be aware that for checkpoint 1, this is the diameter right here. So if you want to use the radius, you're going to have to either multiply or divide by 2. I'll let you think about that for a second, okay? Go ahead and try checkpoints 1, 2, and 3. 1 and 2 are like the first couple we did, and then checkpoint 3 is like the one we just did. Go ahead and pause the video. All right, let's do checkpoint 1. So we're looking for the area of this circle. Area equals pi r squared. Now we know that the diameter equals 9, so is the radius going to be 18 or 4.5? It's going to be 4.5. The radius is half the diameter, so we're going to plug that into the formula. So area equals pi times 4.5. Oops, that was sloppy looking. 4.5 squared. You're just going to multiply that, so it's going to be, and it's probably going to be approximately, actually. Whenever you multiply by pi, it's going to be an approximation because pi goes on forever and it really messes things up, but it's going to be approximately 63.62 centimeters squared. And there you go. All right, let's do the second one now. Now, we're looking for the radius, and we know the area is 154 squared. So we have a equals pi r squared. So this is 154, so we're going to plug 154 in for area. Now, how do we solve for r squared, or how do we solve for r? Are we going to get rid of the squared or the pi first? We're going to divide by pi first. So those are going to cancel. We're going to get r squared, and I'll keep it like this. 154 divided by pi is it's like 49.0 point in change, basically. So we're just going to put 49 for this one. Then how do we undo a square again? We take the square root. So r is going to equal 7. Are we done? Is that what we're looking for? Are we looking for the radius? We are looking for the radius, not the diameter. So this is where we can stop. Okay? All right. And then we're going to do checkpoint 3, example 3. Yeah, we've got a few more to do here. So, okay, checkpoint 3. So, find the areas of the sectors formed by RQS. Here's RQS. All right, so we're looking for the area of the sector. So again, we're going to use area of the sector over area, or pi r squared is going to equal arc measure over 360. So what do we know? Do we know the area of the sector? We do not. So that's going to be x over. Now, do we know the area, or do we know the radius, or the diameter, or do we know else for this circle? This 9 feet is the radius, so we're going to use pi times 9 squared equals, and what's the arc measure? What's the degrees? 106 over 360. Cross multiply. 360x equals, so what I would probably do is I would do 9 squared times pi times 106 to keep things nice and organized, which is approximately 26,973.71 divided by 360, and x is going to be approximately 74.93 feet squared. All right, nice. Okay, we're gonna do example 3, and then checkpoint 4 in B. That's kind of weird how it's 4 in B, but whatever. All right, so example 3. Here we go. Use a diagram to find the area of circle C. So this time we're looking for the area of the whole circle, and we're given the area of the sector over here. So this one's a little bit different. So we're still going to use the same formula. Area of sector over area, or pi r squared, equals arc measure over 360. Okay, do we know the area of the sector for this one? We actually do. It's 22. 22 over. Now, if we're looking for the area of the circle, do you guys think we should use the whole area, or should we use pi r squared? So this is kind of a shortcut. Instead of using pi r squared and then converting it back to area, what I would probably do is just use the area of the whole circle. Call that A. That's going to keep things nice and organized for us. We don't need to like multiply by pi and get confusing here. What's the degrees of the area of the sector there? 45 over 360. Cross multiply. So now we get 45A equals 22 times 360 is 7,920 divided by 45, and A is going to be approximately, or is it equal to? 7,920 divided by, well, it's 176. Equals 176. That's going to be meters squared. Now, does that answer make sense? Should the area of the circle be bigger than the area of the sector? It should, right? The sector is part of the circle, so it shouldn't be smaller than the area of the sector. So it means we did something right. That's like math sense. That makes making sense of the problem. Cool. All right. Why don't you guys go ahead and do checkpoint 4, which is just like the last one, and then we will move into the last example together. All right. So area of circle G. So again, we're using area of the sector over area, or pi r squared, equals arc measure over 360. What do we know for this problem? Do we know the area of the sector? We do. It's 6.4 over. Now we're looking for the area of the whole circle, so are we going to use area or pi r squared? If we're looking for the whole area, let's just use area. And then what's the degrees? It's 80 over 360. Cross multiply. We're going to get 80A equals 2,304. So A is going to be approximately 28.8 yards squared. Okay? So again, if you had the radius, you could just use pi r squared, because you would have the radius, and you could just do, like this last one up here. Yeah. If you had the radius, you could just do area equals pi r squared and just solve it. You don't need to actually use the area of the sector thing then. But if you don't have the radius, you have to use the sector area to help you. So, okay, and the last one I want to be very clear about, because people are still goofing this stuff up, and it is kind of tricky, but don't overthink it, okay? So people are trying to find the area of like the whole shape or something. And what two shapes do you see here for letter B here? I see a triangle. That was really sloppy. Let me fix that. I see a triangle. Dang it. I see a triangle, and I see, what's the shape down here that I'm highlighting? And a semicircle. A triangle and a semicircle. Let me highlight them real quick. Okay, so the way you solve these is you don't get, you're not going to like combine them right away. You're going to split them up. You're going to find the area. So the entire area, let's use green. The area of the shape is going to equal, you find the area of the triangle first, plus the area of the semicircle. Okay, that's what you're going to do. You're going to split them up into two shapes that you know, and you're going to find those areas. So the area of the shape is going to equal, now what's the formula for area of a triangle? Hopefully you know what that is. It's base times height over 2, plus, now we got to think through the area of a semicircle really quick. What is the area of a semicircle? Well, the area of a circle, that's going to equal pi r squared like we talked about. If we want just half a circle, which is a semicircle, what am I going to do to the pi r squared? I'm going to divide it by 2. Okay? So we're going to do pi r squared all over 2. All right. So for the triangle, what's the, it's not the radius. What's the base of the red triangle there? What do you see? 7. And what's the height? 4. So we're going to do, so we're going to do 7 times 4 over 2 plus, and then in blue, we're going to, what's the radius of that circle? So it looks like the diameter is 7, so the radius is going to be what? 3.5. So we're going to do pi times 3.5 squared all over 2. So the area is going to equal, so 7 times 4 is 28, divided by 2 is 14, plus, and then multiply, I would do 3.5 squared, I would do pi times 3.5 squared, and then hit equals, and then divide by 2, okay? And that's going to be, once you do that, you should get, what is it? It's 19.24. So the area of the whole shape, so I'm going to highlight the outside of the whole shape here to make it easier to see. Okay, the area of the whole shape is going to equal, or be approximately, actually, we'll do approximately, 33, once I add those together, 0.24 square feet. Okay? So that's how you approach those problems. Again, if you had something like, if you had a shape like this, you would have, right here, you would have a square. You would find the area of the square, and you would find the area of the, you'd find the area of the rectangle. I'm going to write that down here, actually. Area square plus area of rectangle. Equals the total. All right. So hopefully that made sense. Sorry if it was a little bit of a longer video, but I want to make sure we covered everything and make sure you guys feel good about this stuff. Thank you for watching. Have a great day, and we will talk soon.